Happy Friday Eve, boys and girls. It is Thursday, so I'm so proud of you guys this week that you have done all that work without me being there. That's very impressive. So let's keep it going. Today we are going to multiply a decimal by a decimal using the algorithm. So we have done a lot of modeling this week with the coloring of the grids, and so that's good, but we're going to move to the algorithm today. So I think you guys will enjoy the lesson, and it's not that different from multiplying whole numbers, so it'll be good practice as well. Okay, so last night after I had finished recording my lesson, my daughter asked me, was this the way I taught every day? And I said, well, no, because I don't usually talk into an iPad every day. And she said, good, because that was really boring. So sorry if this isn't the most entertaining video you've ever watched, but it's kind of hard since I have nobody to communicate with, really. I'm not getting a lot of feedback from my iPad. So anyways, but I thought I'd start with a little fun thing today. So maybe my daughter will like this one a little bit better. So I found this on Tumblr. Kind of funny. This is kind of like a time test. Like at the beginning of the year, I think we did one of these on multiplication. So it's one of those timed tests that people stress over. And these are different comments that people had made on this picture. So if you read through them real quick, I think they're pretty funny. Especially this down here. The teachers use this as a weapon to pin us against each other. The legal Hunger Games, the number games. So anyways, I thought that was pretty funny. Okay, so to get started today, we are going to multiply 1 and 7/10 times 2 and 8/10. Okay, so same process that we did on Tuesday. The only thing that's different is today, both of our factors have decimal places. So if you remember on Tuesday, it might have been something like this. Where only one of the factors had a decimal place. And by decimal place, I don't mean decimals. I mean numbers in decimal places. So the only difference today is both of my factors have numbers that have decimal places, or that are in decimal places. So basically we just multiply like normal, like this was a 2-digit by 2-digit number. So we're going to multiply the 8 times the 7 and then the 8 times the 1. So 7 times 8 is 56. 8 times 1 is 8 plus 5 is 13. And I'm done with my 8, done with my 5. I'm going to put my 0 here as I go over to the 2. And then I'm going to do 2 times 7 and then 2 times 1. 2 times 7 is 14. 2 times 1 is 2, plus 1 is 3. I'm going to add those up. 6, 7, oops. How about eraser? There we are. Sorry about that, guys. Okay, so 1 plus 3 is 4. And then we're going to go back up here and look at our factors. 1 and 7/10, we have a 7 in the tenths place. And then 2 and 8/10, we have the 8 in the tenths place. So two numbers are in decimal places. And so we will need to move the decimal 1, 2 places and put it between the 4 and the 7. So our final answer here would be 4 and 76 for the product of 1 and 7/10 and 2 and 8/10. So I know you're thinking, oh, well, that's a piece of cake. And really it is. It's pretty easy for the most part since you guys have been multiplying for a while. Let's try another one. Let's do 32 and 3/10 times 0 and 7/10. Okay, and if you remember from Tuesday, we had talked about when you're multiplying a number such as this, 0 and 7/10, that has a leading 0, it's much easier to multiply this way. So 32 and 3/10 times 7. And then just at the end, when we have the product down here, go back and look at our decimal numbers, or our decimal places. So 3 times 7 is 21. 7 times 2 is 14, plus 2 is 16. And 7 times 3 is 21, plus 1 is 22. So then you would just go back over here and see that there's 1 decimal place, 2 decimal places. And so we would move the decimal once, twice, and it goes right here between the 2 and the 6. So the product would be 22 and 61 hundredths. Back over to this one, this is what would happen if you kept the 0 there. You would multiply, just like we did, the 7 times the 3 times the 2 times the 3. So you would end up with, same thing, 2261. So this is the same partial product as we got over here. And then, normally when we're doing a 3-digit by 2-digit, we cross this out and we put our 0 down here, and then we go to the next digit. Well, that's a 0. And so 0 times 3 and 0 times 2 and 0 times 3 would result in zeros. So as you can see, it's kind of just a waste of paper and space to do that, because you're going to end up with the same answer. So just basically eliminating this row of zeros by taking that 0 out of there. Actually, you don't even really have to take, I don't know why I took the decimal out of there. You can just leave the decimal in there. And that way you can see your 2 decimal places there. A lot of time when you're going to have to multiply decimals in a kind of a real world or a word problem situation, it will look something like this. Here's a good example. So Julie has 5/10 of her backyard set up for growing vegetables. Of the vegetable area, 4/10 has bell peppers in it. What part of the backyard contains bell peppers? So the key word that you're looking for here is this word of. That is huge when you are talking about decimal multiplication. So, and think about it, we had talked about before a lot of times how the multiplication sign meant groups of, and we say that a lot, groups of, when we multiply. And so when you see the word of, that's just kind of the same thing as our groups of, which means you're going to multiply. So you're taking a part of a part is basically what you're doing. So you would set that up, and that's what would tell you that you would be multiplying in this problem. So you would set that up as 0 and 5/10 times 0 and 4/10. Again, we can really just eliminate the need to multiply the zeros. And so we would just multiply 4 times 5 in that case, which is super easy. That is 20. And then you have one decimal place, or one number to the right of the decimal, 2, or just second number to the right of the decimal. And so you would move it 1, 2. You place it before the 2, and so your answer would be 0 and 20 hundredths. Or another way to write that would be 0 and 2 tenths. So either one of those would be the correct way to answer this question. So this is going to come in handy when you are multiplying money. When you're trying to figure out if you have enough money to buy multiple items, if you are trying to leave a tip at a restaurant, you can multiply by decimals. So things like that. So get your guided practice out. If Mrs. Gerhardt hasn't already passed it out, you can pause the video and get it passed out. Make sure your heading's at the top. That would be your first name, last name, classroom number, all that stuff. I'm not sure what number I should put for myself. Of course, I'm number 1, but that's also, let's see, Sarah Barnes's number and Isaiah's number and Ashley's number. But anyways, I don't know what number I would be. We'll have to think on that. Okay, so what I want you to do is, first of all, it says for 1 through 4, estimate first. So they're wanting for you to use your rounding or compatible number skills to estimate the product, then find the actual product, and then check to see if your estimate, or if your answer is reasonable as far as comparing it to your estimate. So the first one we have is 70 cents. Notice it's cents because it's 7. The 7 is after the decimal, and that is 7 tenths of a dollar, times 2 and 5 tenths. So what you're going to do is think about, well, this is close to $1 if I was using rounding, and $1 would be 1, and 1 times any number is that number. So 1 times 2 and 5 tenths would be 2 and 5 tenths. So that's our estimate. So now let's do it for the exact answer. And there's that 0 again. So since it's a leading 0, let's just leave it out so that we can just have a 2-digit by a 2-digit number. So 70 cents times 2 and 5 tenths. So you have 0 times 5 is 0. 5 times 7 is 35. I'm done with the 5. Put my 0. Almost forgot. 2 times 0 is 0. 2 times 7 is 14. Add that up. And I'm running out of room. 5, 7, and 1. Okay, now let's look back up at our factors. We have 70 cents. So we have 1, 2 decimal places. And we have this third one right here after the decimal place. So 1, 2, 3 numbers are after the decimal. And so we would need to move the decimal 1, 2, 3 places. So our answer would be $1.75. We wouldn't want to leave that 0 on the end because when we're talking money, we don't write money to the thousandths place. We just write money to the hundredths place. So that would be our answer on that one. And $1.75 is, erase that, that's bugging me, is close to what we got for our estimate. We estimated 2 5/10 or $2.50. And I mean, that's close. It's not exact, but it's close enough to where we know that we put the decimal in the correct location. For instance, if we got something like 1750, we would know that it was way off of our estimate of 2 5/10. So just a way that estimating can help you there. Okay. All right, so the next one on the guided practice is $26.35 times 6/10. So you're going to set that up vertically because we don't multiply like that. 26 and 35 hundredths, or 35 cents, times 6/10. Notice I left the 0 off. We don't want to mess with that. And I know that you have done some 4-by-1 multiplication in 4th grade, so that shouldn't be a big deal. So we're just going to multiply the 6 times the 5, the 6 times the 3, 6 times 6, 6 times 2, and all of that will be on one row. It will be one partial product. So 6 times 5 is 30. 6 times 3 is 18 plus 3 is 21. 6 times 6 is 36 plus 2 is 38. And then 6 times 2 is 12 plus 3 is 15. I hope I'm not making any calculation errors on this. If I do, you guys write it down, and when I come back, you can tell me about it, and I'll give you Tiger Bucks. So, all right, and then the next step would be to look at our factors. Our first factor is $26.35. There is 2 decimal numbers, or 2 numbers after the decimal. And then in our second factor, there's 1 number after the decimal. So that's a total of 1, 2, 3. So we're going to start here at the end, move it 1, 2, 3, right there between the 5 and the 8. And so the answer to that one would be $15.81. Okay, number 3, $3.60 times 12. So that's like you go to the store, something costs $3.60, and you're buying 12 of them. And that is a decimal times a whole number. So that's going to look a little bit different. Think about Tuesday when we colored the grids versus yesterday. Or, I'm sorry, I keep saying Tuesday. Monday when we colored the grids versus yesterday when you colored the grids. Remember how different the models looked. So, so you're going to write it vertically just like we normally do. $3.60 times 12. We're going to multiply this 2 by every number on the top. So we're actually doing 360 times 2. And that's going to be right here. Then we're going to go to the 1, which is actually in the tens place. And we're going to multiply 360 times a 10. And that will be the second partial product. So 0 times 2 is 0. 2 times 6 is 12. 2 times 3 is 6. Plus 1 is 7. I'm done with the 2 and done with that. I'm going to bring my 0 down. 1 times 0 is 0. 1 times 6 is 6. 1 times 3 is 3. I'm going to add those up. And then I'm going to go back up here and look at my factors. Remember, the 12 is a whole number, and so there's no decimal places after the decimal, because the decimal would be right here after the 2. So there's nothing there. In our first factor, $3.60, there's 1, 2 numbers after the decimal. And so we will move the decimal 1, 2 places. It will go here. So our answer to that one would be $43.20. And then number 4, write it vertically. And don't be lazy and write it right underneath here. Don't write an 8 right here. That's being lazy. Times 8. And so here again we have a decimal number multiplied by a whole number. So 8 times 0 is 0. 8 times 9 is 72. 8 times 4 is 32. Plus 7 is 39. And then 8 times 1 is 8, plus 1 or plus 3 is 11. And so our first factor has 1, 2 numbers after the decimal. Our second factor has none. It's a whole number. So we're going to move the decimal 2 times. 1, 2 places. Place it between the 9 and the 2. And our answer is $119.20. Okay, so here is an example of how you would put this to use in real life. So here's a word problem, and I want you and your elbow partner to work on this together for about, oh, I don't know, 5 minutes maybe. Mrs. Gerhart can give you about 5 minutes. Work on it together, come up with an answer, and then Mrs. Gerhart can call on a couple of you to talk about what you did, what you talked about, the answer that you came up with, and why, and stuff like that. So you can pause the video right now and pick it up when you are done with the discussion. Okay, so hopefully you have worked the problem with your partner and you've discussed it and you've shared out a little bit. Hopefully you came up with the answer of $8.90 as far as how much Mary spent. But did you notice this question down here about estimating first to decide if Mary Ann spent more than $10? So if she was going to purchase these items and she knew she only had $10, really easy way that you could estimate that in your head would be to think about, well, she's ordering 3 pens and each pen cost $1.65, so 3 pens, and I'm just going to round $1.65 to $2. And instead of writing $2, I'm just going to write, keep it 2, because it's a whole number. And so that would be $6. And then she ordered a box of paper, and the paper cost $3.95 per box. Per is another word for each. So per and each mean the same thing. So she bought 1 box of paper, and I would estimate $3.95 to be about $4. And so that would be 4. And if you add 6 plus 4, of course, that equals 10. So to answer this question down here, yes, I got 10 when I estimated, but did I overestimate or underestimate $1.65? I definitely overestimated it because I went up to $2 per pen. And I did the same thing with the box of paper. I overestimated it 5 cents to round it to $4. So you know that she's not going to spend more than $10, because even though our estimate is $10, we overestimated the price of the items, and so we know that it's going to be below $10, the actual cost. And that's a useful skill when you're estimating dollar amounts and it's you that's going to spend the money. It's always good to overestimate or round up than it is to underestimate or round down, because you don't want to be stuck without enough money to make your purchases. You always want to overestimate, and that way that won't happen. Okay, so hopefully you've had some practice and you're ready to tackle some on your own. So I want you to do the independent practice. So that's questions or problems 7 through 18, which is the front of that page that you have right there of page 173. If you want to use extra paper, scratch paper, grid paper, that would be fine, because you might have a little bit more room to work. I have clipped these two problems. These are on the back of your paper, question 19, 20, and 21. These are really good examples of how you might see the use of multiplying with decimal numbers, as far as how that they would come up in a word problem in real life situations. And so I really want you to do if you have time and you get through with 7 through 18, I would really, really like you to at least do 19, 20, and 21 on the back. If you want to do some more, you have time, that'd be great. If you run out of time with the front work, that's okay too, but just know that you're never going to, on a test that you're going to take on these skills, they're not just going to write a problem with the two factors and just tell you to multiply. You're going to have to read and analyze for information and decide what operation you're going to use and how you're going to kind of attack that word problem. So these are really good examples of how you might see this skill tested. So I really want you to read over it. Even if you don't have a chance to solve them, go ahead and read over it. So what's pretty cool is now that you know how to multiply decimal numbers, decimal by a decimal, using the algorithm, you can be your family's personal tip calculator. The next time you go out to eat, you can just tell your mom, dad, grandma, aunt, you can just say, oh, no, you can put your phone up. You don't need that calculator. I will calculate the tip for tonight. So depending on how good the wait staff is, a good rule of thumb is to leave 15% of the bill. And 15% is equal to 1500ths. And so say you and your family go out to eat and the bill is $42.10. Let's just say. So you're going to take 15% of, there's that word of, the bill. And so that's multiplication. And so you're going to multiply it by 15% or 1500ths. And so let's just do it real quick. So we're going to take this, multiply by each number on the top, and that's going to be here. Then we're going to go over here and multiply that by each number on the top. That will be our second row, and then we'll be done. So 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10. And 5 times 4 is 20. Plus 1 is 21. Done, done. 1 times 0 is, oh, put my 0. And then 1 times 0 is 0. 1 times 1 is 1. 1 times 2 is 2. 1 times 4 is 4. Add that up. 0, 5, 0.51336. And we'll come back up here and we'll look at the decimal places. There's 1, 2, 3, 4 numbers after the decimal. So that'll be 1, 2, 3, 4. So our decimal will go between the 6 and the 3. And so a good tip, if you're going to leave 15%, would be you would add $6.32 as the tip, because you want to round to the nearest hundredth. Because dealing with money, we don't write money with thousandths or 10,000ths. So if we round to the hundredths place, we would look next door to the right, and the 5 tells us to give it a shove. So we're going to give that one a shove and become a 2. And so $6.32 would be the tip that you would add on to your total bill at the restaurant. And so you would add this with your tip, and then you would have a total that would be you would pay, or that you would be charged, or sometimes grown-ups just leave the tip on the table in cash. So anyways, so that is a useful thing. You can go home and tell your parents that you know how to figure the tip on a restaurant bill. You can also, depending on how good the waiter or the waitress is, you can leave them more than 15%. You could leave them 18% or 20%. 18% would be, of course, 1800ths, and 20% would be 2000ths. So hopefully you won't have a bad experience, because sometimes waiters and waitresses get gypped if they have unhappy customers. So hopefully you wouldn't have that kind of experience. So, but anyways, I thought that would be kind of fun to teach you guys kind of a real life use of multiplying with decimals. Now go get to work. See y'all tomorrow.